Hello everybody. Welcome back to IDAE Digital Academy for Engineering. And in today's video, I want to show you guys a very nice way of generating volume capacity tables for storage tanks. Okay. Now, in this case, I have a horizontal storage tank like this one. Okay. We'll generate the capacity table for this one, or we'll show you at least how to do it, how to generate the capacity table. Okay. This is especially very useful. This method is especially very useful for finding the capacity tables, for generating the capacity tables of horizontal storage tanks. Okay. You can also use it for vertical storage tanks as well, but it's very much useful for horizontal ones. Okay. So real quick, I want to show you how this is done. I have SolidWorks opened here. I want to click File. I want to click New. I want to click Part, and I want to click OK. So basically, what we're going to do right now is we're going to draw the 2D sketch. This one in SolidWorks. These dimensions are obviously actual dimensions measured on site. Okay, this is very important. If you don't have the actual dimensions, this capacity table would never be accurate. Okay, regardless of that, let's real quick draw this 2D sketch in SolidWorks. Okay, so I can work on front plane. I usually work on front plane for tanks like these. I'll click Sketch, and then I'll click on midpoint line. I'll draw the line, and I'll click on Smart Dimensions. I will identify the dimension of this midline. So this one is basically this line here. Okay, what's the length for that? It's 9.715 meters. So 9.715 meters. Okay. And now I need to draw the dish ends. Okay. You see the dish ends. There are two dish ends, but unfortunately, this drawing is not an accurate one. Sorry, I've got no internet. I want to view the. Give me a second. Okay, back online. So actually, I have the drawing here and downloads. Yep. So as you can see, the dish ends, we've got two radiuses here. Okay, 362, 1880. Okay. But in this drawing, it's not quite accurate. Regardless, we'll use the design radiuses for this case. Okay. So the first radius is 362 and the second one is 1880. Let me real quick draw these for you guys as well. I'll click on the line tool. I'll come here and I'll draw the first radius, and then I will draw the second radius. Okay. Now we'll give it the so this one was 0.362. Okay, and then that one is 1.880. Okay, and then I need to identify a couple of more points. Let's get back to the drawing. Okay, so as you can see, the distance HD between the cylinder and the midpoint of the dish end is 0.642. Okay, so let me real quick put this dimension there, 0.642. Okay, so that's one dimension. Now I need to identify the vertical height, this one. The vertical height would be, sorry, terribly sorry. The vertical height would be basically half the diameter or the radius of this cylinder. Okay, I know the diameter here, it's 2.338, so I know that. I know the height. Okay, so I'll click on this point and I'll click on this point, and the height difference between these ones are 2.338 divided by 2. Okay, hope that makes sense. I'll click enter. Okay, so now everything is fully defined. I just need to mirror some entities, and for that, first I will draw some some construction lines. So this one is for construction and infinite length. It's vertical, okay. And to make it fully defined, do this. Now we'll mirror these ones, okay. So I'll click on these two entities here, the dish ends, and I'll say mirror entities, and I'll mirror them about this line, okay. And I'll click OK. Now everything is fine. I'll draw another construction line, okay. I'll click on it. I'll say for construction infinite length, and I'll click on this one. I'll say they are perpendicular, okay. So that makes this line fully defined as well, okay. So now everything is fully defined, okay. Everything is fully defined in this SolidWorks sketch. I need to complete the tank drawing. Now remember, these dimensions are taken from inside the tank. So if I can find the volume of these dimensions, it means I have the volume of the full tank, okay. Now to complete this thing, I first need to turn this into a 3D model, okay. It's quite easy because I did the drawing this way because I want to use the feature. I want to use the revolve feature, okay. If I click on revolve, and if I give it the axis of rotation as this one, it automatically turns this into a 3D model for me. So right now, think of this as the fluid inside the tank, okay. So if I can find the volume of this fluid, it means I already have the volume of the full tank, okay. So let me click here, evaluate and mass properties. It will give me instantly the volume of the full tank, 45.17 cubic meters, okay. So I can instantly compare this with what they've given me, okay. Again, I think I lost. Oh no, I'm back online. Sorry, let me refresh the page first and click here. Yeah. So as you can see, the volume they have calculated is 45.3, okay. So 0.2 cubic meters error is in their calculations. This one is 45.17, okay. Now obviously this is more than 0.2 because let me show you one thing. Yeah, because this one 45.3 it means subtracting all the internal structures as well. So this is the internal volume of only one pipe structure, okay. So if you subtract all of this, the volume would be actually less than that as well. But regardless, I hope this makes sense right now. So we can find the total volume. And now I want to find the volume of each and every cross section, okay? Each and every cross section. So how I can do this is I'll use top plane. I'll make it visible, okay, so I can see this. And I will click on this plane. And so what I'm going to do is I'm going to go to features, and I'm going to click on reference geometry. I'm going to click on plane, okay. So I'm going to make another plane 1 centimeter above this one, okay. So this way we will cut through the tank, okay. We will cut through the tank 1 centimeter. So we're gonna measure the volume of this 1 centimeter, okay. Regardless, I'll just click yes. So right now I have this one here. Let's think. This is another. It's another plane. But I will delete this one because I want to show you guys a faster way of dividing the tank into many 1 centimeter cross sections. You can just click here, and then you can click on. Let me see. And you can click maybe on. I'm sorry, I need a second to. Okay, so I'll click on plane. I'll click on this plane again. It gives me 1 centimeter. That's great. That's miraculous. So now I'll click on linear pattern. Okay. I'll click on linear pattern, and so I've defined that I need 233 of 0.01 meters divisions, and I don't need to linear pattern features and faces. I need to linear pattern reference geometries, and in this case I want to linear pattern this guy. Okay, so as you can see, we'll cut through all of it. I need 234, 5, I think, yeah. So right now we're dividing in full the tank into 1 centimeter cross sections. Okay, we'll click OK, and this will instantly generate all these planes for us. Okay, and I think I don't need this plane. Yeah, I'll just delete that plane. I'll click yes. I don't know, for some reason the other planes are gone. Let me do this real quick again. Reference geometries. I need this guy. Okay, so the direction is that, and the reference geometry. Okay, so sorry. Okay, so we'll just use these planes. I don't want to make this video longer. Anyways, real quick, what we want to do is we want to select all these planes. Okay, so I'll click Control and Shift at the same time. I'm going to click all of these. Okay, and so this selects all these planes, and what I want to do is I want to go to Tools. Actually, I want to go to Insert, Mold, and Split. Okay, and I already have selected all the planes. Scroll down, and I'll say Progressive Visual Properties. I'll say Cut Part. So I will cut through my part. I will split the tank into 1 centimeter cross sections, and then I'm going to say to assign titles. Okay. Oh yeah, sorry. So let's save this first. So File. Okay, before we do anything, let me just. Okay, this might take some time. Okay, let me save this model first. I'll save it as part 2 on my desktop. I'll click Save. And now again, what I'm gonna do is I'm gonna click Control and Shift, get down and select all of these planes. Okay, now I want to select the first plane as well, so I'll click I'll click Control and select the top plane as well. Okay, and right now I'll get back here into Insert, Mold, and say Split. Okay, and we're going to cut the part. Okay, we'll scroll down, we'll click on this one, we'll say U2 assign titles. It's all assigned. So now I'll say split. And we have to wait for some time here because right now what SOLIDWORKS is doing is getting all these cross sections, okay, and it's saving it as a different model because it needs to treat it as a different model. Okay, this will take some time, so I'll be back when this is done. Okay, thank you. Okay, so taking more than what I expected, but anyways, so we'll wait till this is done, and then so as this is working, I want to show you guys something else. So back here, yeah. So as you can see, we have volume rise. Okay, this means the volume in this centimeter, in between these centimeters. Okay, so in SOLIDWORKS right now, we can easily, without taking a look at like the full volume, we can take a look at the error. Okay, I think this is, for some reason it thrown me back into this page. Anyways, so we're going to look at the error on 185 centimeters. We're going to see the cross-sectional volume for that single centimeter, and we're going to look at the error, what the error is. Okay, anyways, let's see, because we already know that the full volume is not accurately calculated in this case, so we know that there is some error in cross-sectional volumes as well. Okay, but let's give SOLIDWORKS some more time. So these buddies you see here, they're only number 1 to 10. Okay, buddies 1 to 10. Otherwise, we have quite a lot of buddies. As you can see, I think we have 234 of them because of the height of the tank or the diameter of the tank or whatever. But yeah. Now, if you have a very uneven tank, like the diameter changes quite a lot, from point to point. You can also do this using SolidWorks, but you need more skills. You need to be skillful in terms of drawing the 2D sketch of the tank, or in some cases you need to draw the full tank and then work on it in its 3D model. You need to edit some parts in 3D models if you want very accurate capacity tables. But usually this is not required because you usually are not looking at this very high accuracy. Okay, especially considering that the tank is above 45 cubic meters. You're not looking for any volume that is like 0.00002 cubic meters or less. You don't care about these volumes, so it's not that important. Any deformation or anything of that sort is not very important, to be honest. Regardless, okay, seems like everything's done. To see if this has actually worked, I'll click on this plane, I'll scroll down, click Control Shift, and when all the planes are selected, I'll right click and say hide these planes. Okay, so everything is hidden now, and as you can see, the tank is split into 1 centimeter cross sections. Okay, so now what you can do is you can again come to evaluate. Let me turn this off. You can come back to evaluate and click on mass properties, and you'll get the full you'll get the volume of the full tank. Okay, but let's do one more thing. Let's increase the resolution of this to 4. What I want to do is go to files, maybe. I think that's where I can tools, options maybe, and then document options, and then units, and then from here I can change the resolution. So I'll say I'll turn everything to 4 decimal points, and I'll click OK. Okay, so now everything is in 4 decimal points. If I click on mass properties again, I'll get the more accurate volume. Okay, now I don't need to select the full part. I'll just delete this part. Okay, and I'll select one line here, one cross section here. Okay, so at height of 0.275, this is the volume. Okay, this is the cross-sectional volume. It's 0.1554. So if I refer back to this height, okay, to this height, or to any other height, okay, but let me actually delete these. Yeah, let me refer to this height, for example. Okay, or to this height, or to this height. Any height, you can select any height really, any cross section. But let's say I chose this cross section. So at height of 1.169, okay, so that's 116. So 116 or 115, what is the okay, sorry, this is the this is the, yeah, so this is the cross-sectional volume. So right now at 0.53, okay, so let's check 0.53. The volume here is 0.2063 cubic meters, and if I check back here at 53 centimeters, okay, it's 0.2061, and here is 0.2063. okay, so pretty good. But this error will increase as you go further up and further up. This error will increase. Like for example, if I check, let me delete all of this. If I check at height of 122, okay, if the volume here is 0.2480, let's check what the volume is in the other table. Okay, so 122. So 122, the volume here, the cross-sectional volume is 0.2526, 0.25246, 2526. As you can see, the error is more in this case, okay? But as you go further up, the error decreases again. Yeah, so this is how you can generate these capacity tables of tanks here in SolidWorks. Obviously, you can do this for all these cross sections of the tank and get the volume from the mass properties. You can automate this with a macro. You can generate the table automatically, but that would be for another video. But all I wanted to show you is that you can generate this capacity tables using SolidWorks. But obviously there are some other things. If you want high accuracy, high precision, these actual taken dimensions should be temperature corrected. The tool used for measuring these dimensions should be also temperature corrected, and the reported volume in your report should be at standard temperature, which is 15 Celsius. Okay, but all that aside, this is how easy it is to just draw your 2D sketch in SolidWorks and just get the volume of it. Okay, and then you can easily generate the capacity table, the volume capacity table for your tank. Okay, and then you can subtract any internal structures that are in, or you can also put that in your model. You can also draw that in your model. Your SolidWorks would automatically calculate that for you. Anyway, so that was it for this video. Thank you. Thanks very much. Cheers. Bye-bye.